So this problem should give us more practice. It's a moderate to difficult problem. The first thing we're going to do is read the problem carefully to see what kind of information we can extract. So let's read along carefully and writing down all of our givens and unknowns. So point charges of Q1 equals 5.90 microcoulombs. That's the first thing. And then the next item is negative Q2 is equal to negative 5.54 microcoulombs. Are placed on an x-axis at x1 equals 8 meters and x2 equals 15 meters. So this tells you to list some givens, namely Q1 is equal to 5.90 microcoulombs. So we can keep the micro for now. We don't have to convert it to scientific notation. And Q1 is located at the coordinate x1 equals 8 meters. Q2 is written like this, minus Q2, which means that the variable Q2 itself is positive, and putting a minus sign gives the whole charge negative. Okay, and I'll explain a little bit why it was written like this. Negative 5.54 microcoulombs, and x2 equals 15 meters. Continuing reading the problem further, we see that it asks what charge Q3 must be placed at x3 equals 21 meters so that any charge Q4 placed at the origin will experience no electrostatic force. So this may sound confusing, but we'll see that if we draw a picture, it'll make everything very clear. So we're going to draw a picture of number lines, since everything's happening on the x-axis of what's going on with these, where these charges are placed. So here's a x-axis going from left to right, and the numbers here are, the highest number is 21 meters. So we can say put 0 here, and the furthest over here would be 30. That means we divide this equal into thirds, so say 10 is here and 20 is here. It doesn't have to be exact, we just need to know where everything is for the charges are. So actually I'll just move this over a little bit, make it better. 10, 0, 10, and 20. And we have Q1 at 8 meters. So somewhere here is Q1, and it's located at x1 from the origin, 8 meters. Q2, or minus Q2 actually, is located at 15 meters. So it's right here at the center, minus Q2, located at x2. And then last is Q3. We want to put it at 21 meters, somewhere around here. Q3 at x3 equals 21 meters. Okay, actually this is also a given, so what is Q3 is the unknown, we want to know, and x3 is known, it's at 21 meters. So those are all of our givens and unknowns and what we're trying to find. There's going to be if you read it again, there's a force, a charge Q4 at the origin, and we want to put that Q4 at the origin. Experiences forces from Q1 and negative Q2 and Q3 that the sum of the forces will give you 0. So it doesn't matter what charge Q4 is, all these forces will always add up to give 0 force on Q4. If we were going to do a free body diagram, you would have forces on Q4. Q1 and 4 assume positive, so Q4 would get a repulsive force pushing it to the left like this, F1. And negative Q2, since Q2 is positive again, negative would be negative charge, which would attract Q4, and so there would be a force from Q2 going to the right. Finally, Q3 is the same sign as Q4, so then it would feel a repulsive force, F3 going to the left. So this is Q4. So what type of problem is this? Well, definitely this is electrostatic force problem, but really at the heart of it, it's a general physics, Newton's static equilibrium problem, where the sum of the forces will equal 0. So what we have to do here is basically sum these 3 forces that are acting on Q4, sum the forces in the x direction. So F1 is to the left, so it's negative F1. F2 is to the right, and then minus F3 since it's to the left, and set it equal to 0. Okay. So far we haven't done anything. This is just a Newton's second law problem. And now we're going to put in what these forces are using the Coulomb force equation. See, so my negative F1 is going to be the electrostatic constant K times the charge of one Q4 multiplied by the charge of Q1. So Q4 times Q1 over the distance between them. And conveniently, Q4 is at the origin, so the distance between them is just x1 squared. Next is F2. F2, we're looking at just the magnitude because we already accounted for the sign of F2 by this plus sign. So we don't want to double count. We don't want to put positive K, Q4, and again, we don't want to put negative Q2 because we already accounted for the sign. And then the distance Q2 is from the origin is x2 squared. Last will be F3. We have minus K Q4 times Q3 over the distance x3 squared, and you set that equal to 0. So notice I haven't put in any numbers. These are all variables. And I remind you that we want to do that because when we work with variables, there are many benefits. First benefit is we don't have to punch in so many numbers. If we make a mistake, we wouldn't know where our mistake occurred. We'd have to redo the calculation. And then a big reason was you can see cancellations. You can simplify your work. So in this case, there are actually cancellations. If there are factors that appear in every term and the other side is 0, you can cancel it. So here, K appears in every term, so we can cancel it. This other side has 0, so that allows us to cancel. Another factor that appears in all these terms is Q4, so we can actually cancel that as well. And what you have is a much simpler expression. Have minus Q1 over x1 squared Q2 over x2 squared plus Q3 over x3 squared equal to 0. Now recall what we're trying to do. We're trying to find Q3, so why don't we just try to solve for Q3 here. Q3 equals, we're going to solve for Q3 by bringing it to, oh, sorry, there's a mistake here. This is actually minus. We're going to take this whole term you see here and bring it to the other side. That's the first step we're going to do. Bring it to this side, and when you do that, the minus sign so we'll have positive Q3 over X3 squared equal to what's left over, minus Q1 over X1 squared plus Q2 over X2 squared. Okay, and the last step to get Q3 will be multiplying everything by X3 squared. That'll cancel the X3 on the left here. Q3 equals X3 squared over Q1 over X1 squared plus Q2 over X2 squared, close parentheses. Okay, so here's the step now that we should put in the numbers. What you notice though is that since we have Q's X3 squared on the top and then something with distance squared on the bottom, the units will cancel. That means whatever units Q1 and Q2 are will be the same units for, will determine the units for Q3. So we don't have to change units for Q1 and Q2. We can just put them in. 3 is 21 meters squared over Q1, which we recall is 5.90 microcoulombs, over X1 squared, which is 8 meters. And this is a minus sign. And then we have a plus. Q2 is 5.54 microcoulombs over X2, 15 meters. Don't forget that you have to square the whole quantity and not just the meters. You have to square the meters as well, not just 15. And close parentheses. So now you can take a calculator and actually do it. So I'm going to remind you again, we don't have to convert the micrometers into 10 to minus 6 coulombs. We can keep it the way it is, because then when these meters cancel, the meter squareds cancel, the units will be in microcoulombs, which will be a perfectly legitimate unit for Q3. So if you punch this in, you'll get minus 29.8 microcoulombs, and we can box our answers. So you notice that even though we assumed Q3 was positive and did all our math and physics and everything, assuming it's positive, the final answer is negative. What this means is when we originally looked at the force on Q4, we said that the force for Q4 is to the left, but actually, since it's negative, it's actually going to the right. It's attracting Q4.